Greetings of the day. I am Mr. Shahad P, working as Assistant Professor in the Department of Artificial Intelligence, Madanapalle Institute of Technology and Science. Today, I am going to discuss about the very common and most important regression method that is called linear regression. And we people are normally did the same linear regression in the 9th standard or maybe 10th, 11th or 12th standards with pen and papers. And we, as an engineering student, we are using Python or any other programming languages to find the regression equation. Basically, simple linear regression means we are trying to find the equation y equal to mx plus c. So here in today's session, what I'm going to show is with Excel how we can formulate or how we can find this linear regression equation or regression line equation y equal to mx plus v. So for that, I'm taking some examples. For the time being, I'm considering only two variables. One is dependent variable and another one is independent variable. So here we are taking age and height. We know normally the age and height are correlated, especially up to the age of 21 or up to 22, 23, like that it will be linearly connected. So here we are considering one such a small regression equation, regression related data set. Now we are creating a new sheet with the two columns. We are taking a new sheet and we are considering a small data set. Say this data set contains only 10 elements, age and height related values, age in years and height in centimeters. So this is basically a small data set and we know how to draw a regression line for this particular normal or very simple linear regression case. We just select this particular data, go to the insert tab, then we can go for scatter plot. You can see how this particular values are connected. From these dots itself, it is very clear that they are linearly connected. We can do the decorations over here. Axis titles you can give. There you can mention your height. In y-axis you mentioned height and in x-axis we are giving age. Now you see a scatter plot is ready. Now just we want to form a regression line along with the regression equation. Okay, so for that we need to click on this plus symbol. At the end you can see a trend line. There you can see linear, exponential, linear forecast. So many options are there. In this case we are trying to plot or trying to find a linear regression line. So click on linear. Then you can see more options at the last. There you click on more options. You can see many options over here. Since we are planning to get a regression equation, we are clicking on display equation on the chart. And along with that, we are trying to find the R square value so that we can understand how much these both values are correlated. The correlation coefficient value R square is also trying to print over this particular line. So the things are ready. Now it is displaying over here in the regression line. So we can see that this particular box is available. We can drag it somewhere and we can make it visible for everyone. We can increase the size and normal formatting we can do so that others or those who are referring this particular figure can easily understand what exactly the content in this particular graph. So see, here you can find the regression equation along with the performance or R square value. So R square value equal to 1 in the sense they both are that much correlated, and this a perfect correlation. Whenever the age increases, height is also increases. So from this, according to this formula, we can find the y value, the height value, if we got any age vector. Suppose we are getting age as 15. You can say at the age of 15, your height will be y equal to 5 star, age is 15 plus 75 equal to 150 will be your height when you reach into the age of 15. So this kind of regression lines we can easily obtain with the help of linear regression support from the Excel part. Now the point is where we can use this Excel, why we are going for the Python or any other programming languages even though we are having Excel and Excel support. So that is what I'm going to expand. The Excel won't support all the kinds of regressions, especially multilinear regressions and all. We need to do more effort or some kinds of restrictions in terms of the dataset sizes, the time taken for plotting this regression line. All these kind of barriers are there, or pre-processing task also we cannot do as easily like any other programming languages. But still, for a normal purpose or a common a teacher purpose or a small data set or small data related works, we can go for this particular very basic regression work. Suppose we want to go for an analysis and a somewhat multi linear regression, the dependence of a particular variable on more than one variable. Here we are given an example of x depends or y depending on x, height depends on the x. So only two variable, one variable that is for height, one variable for age. That is very easy. But when we are considering a big data set or more dimensional data set, more feature data set, then we have to go for another add-in which is available in Excel. So that is called this data analysis. So data analysis tab is available in my Excel. Maybe in your Excel it may not be available. If that is the case, you can go into file, then you can see options. There you can see add-ins. In add-ins, you can find analysis tool pack. There you can click OK. Then you can see this data analysis tab. In my case, it is already added, so I am skipping this part. So first I'm considering a suitable data set. Say here I already have one data set. That is okay, that is like age, height, exercise, hours per week and weight. These four factors are there, and we are considering this for constructing a multilinear regression equation. We know in multilinear regression y equal to, instead of y equal to mx plus c, we can have y equal to m1 x1 plus m2 x2 plus m3 x3 plus c. So we can have multiple dependencies or correlation factors we can consider. So in this case also, the age, height, exercise, these three things are keeping us dependent variables, and y is all these are independent variables, and y is weight, that is dependent variable which depends on age, height and exercise. So that is the case. We consider this data set and we are pasting it over here. Now how we can obtain a regression equation. So first of all, you can go into the data tab. There you can see a data analysis tab. Now in the data analysis tab, you can see a regression option. Regression option is available here. Click on OK. Then it is asking for input y range and input x range. Since here we are considering only one y variable, so this weight is considered as y range along with the label. So we are marking over here as the labels. Then we have three variables: age, height and exercise. That is also selected and given it as x range. We are setting the confidence level into the default value 95. So this is the initial setting. Now once we click on OK, you can see coefficient values here. This is what the basic thing you have to remind or you have to understand. Y equal to m1 x1 plus m2 x2 plus m3 x3 plus c. Say this is the case over here. In our case, we have three coefficients, three variables: y equal to, one second. In this case, we want to get an equation y equal to m1 x1 plus m2 x2 plus m3 x3 plus c is the final equation we want to obtain from this particular Excel sheet. So this is what our aim: m1 x1 plus m2 x2 plus m3 x3. Okay, x3. So now see, here we got only three coefficients. Actually 4 coefficients are there. In age case it is 0. So it says age and weight, our y variable, age and weight. We have three variables: age, height and exercise, and weight is also there. Here age, height, exercise all are having some role in defining weight, but according to the coefficients, here we got one 0 value that we have to discuss. Other than that, we just write the coefficient values. Intercept is given as 37.54. 37.54. So C value we got as 37.54. Say, then M1 X1. First part, M1 X1 is X1, we know it is age. M1 is 0. Here it is 0. We got the coefficient as 0. Now M2 X2. M2 X2. M2 we got minus 0.37. Say we are keeping it as minus 0.37. And M3 X3. M3 X3. So this part also we can construct from the given Excel result. M3 X3, that is equal to, definitely X3 is X2. We got X2 as height and exercise. Height and exercise. Height is here. Here it is weight along with the coefficient value. We have to add the coefficient value. Coefficient value is available here. 5.4. Say 5.4. So these three we got, or all the factors we got. Simply we can finalize here. y value, your y, that is your weight. Your weight is determined by age, height, and weight along with the values like this: 5.4 into weight, 0 into age, 0 into age, say 0 into age plus 0, here it is minus, so 0.37 into height, 0.37 into height, and finally 0.54 into weight plus 37.54. Maybe you can keep at the beginning or at the end, anywhere it is same effect. So this is what the equation we can obtain from the given Excel sheet. So this is basically the regression equation we are obtaining with the help of data analysis tab. Now here we can see there is a connection between age and weight, but here they have given a value as 0. That means some of the features or the correlation between some features are 1, or if any one variable is there, we can interpret the other also. So in such cases, in machine learning and all, we can drop some columns and we can do the analysis. But in this case, we can do it and we can proceed. But before that, we can understand how they correlated. Age and height correlation we can calculate, and we can obtain a different formula or a different same way we can generate this regression equation by removing this age factor. So for that we need to analyze a regression correlation value between height and age. So these both are correlated that much, so it got the value as 0. So by skipping that we can do the same experiment and we will get even same result, but we can see that column is dropped, still we are getting same values. So 37.59 minus 0.37 and 5.4. So here one factor is affecting in a negative direction and another factor is affecting in a positive direction. If you are exercising more, then this particular, sorry, here it is not weight, your weight is decided by your exercise. Okay. So the factors which are connecting weight and height, age and exercise, all these can be formed with the help of linear regression, multilinear regression, and that too we can obtain with the help of Excel formulas that is explained over here in this particular experiment. So those that are starting into this particular field of regression analysis and all, they have to explore more about all these different parameters. What is R square value, as I told, the correlation coefficient value. So normally we prefer the value which is very close to 1 is a good value. The correlation will be more. Here it is a very good correlation. So R square value we got as 0.98. So many other factors, standard error is there, observations count, then analysis on variance, the degree of freedom, sum of squares, mean square. So all significance factors, T static, everything we can obtain in this simple Excel tool, that is data analysis tool for regression analysis. So for basic and very simple regression task, we can go for the scatter plot. From there you can go for the trend line. If there are multiple regressions or multiple variables which is depending on the target variable, then you can go for this data analysis tab. But if the count of instances or the rows is very high, it may take more time. And if you want to go for feature eliminations or dropping of some columns and all, then it is somewhat difficult to do with the Excel part. Then we are preferring normal machine learning task. But this basic Excel work is intended for now common faculty who is not so much expert in any other programming languages and all. They can use it. So sometimes you can see some non-linear data set. See here, I'm taking another non-linear data set. Non-linear data set. You can see once you are plotting normal scatter plot over this particular data set, you can see that this graph is not following a linear connection or linear connection between this age and weight. So in these cases, you can draw trend line with the help of linear regression. Then you can see the R square value, how the R square value is trend line. Here you can see one more option, linear line. Then you can display equation on the chart. R square value also you can display here. So it is giving an R square value of 0.948. It is not so bad, but still you can see that this line or the scattered plots are not exactly falling on the linear regression line. So there we can try some other lines which are available in normal simple scatter plot. So we will go for that particular line. Now you can see here the values are even like R square value is 0.948 only. So that is not that much good as compared to uh, another methods. So try to do one more option. Here we have in trend line, we can see another options. Exponential plot is there, linear forecast is there, moving average is there. So we'll go for more options and we'll go with exponential relationship between the x and y variable. Here it is age and weight. So now you can see that most of the points are falling on the exponential line. So the exponential connection, sudden increase in some variable values based on some age factor, suddenly it is increasing the weight, that kind of relation is existing, then this kind of exponential regression you can apply. So based on the purpose or type of the data distributions, the way of the points are arranged, we can choose either linear regression, logarithmic regression, polynomial, or moving or power type of line plotting, different kinds of regressions or the plots we can obtain in the simple scatter plot. So here I am opting another exponential, and there I'm trying to display the equation y equal to a e power ax. So in that case, R square value is also trying to plot it over here. Now you can see R square value is much better than earlier. Earlier we got with the 9.44 or 45, whatever it is, 0.94 only. But while we are moving into exponential graph, we got it as 0.994. So that is a better option as compared to the previous one, while we are getting a kind of non-linear, not exactly linear type of data set. So these are some of the options that you can apply for analyzing or obtaining linear regression formula as a beginner, or if your data set is very small. So you can use this kind of technique to analyze your data and get the linear regression equation. That is for today. A more detailed analysis of all the field in this particular Excel sheet, in this particular report generated by regression analysis, is also very important, so that we can explore on the next session. Thank you for listening me. Thank you.